It's a continuation of the long division notes for section 3.3. There's a problem up there in the upper right corner if you want to try to decipher through that if you didn't watch the part 2 video. But what I will point out is they operate kind of under the same principle as a normal division problem. So that one on the left, the one on the right, believe it or not, very similar. All right, I'm going to start off number 4 here, and I'll try to leave that one in the upper right corner for you to look at and compare to. But essentially, here's, in my opinion, the best way to do this. You want to start off by asking yourself, the first digit, which in this case is a 1, goes into the first digit in here, which is also understood to be 1, how many times? Well, 1 goes into 1 once, right? So we got that. And then I'm going to cut to the chase on the shortcut here. Just think of it this way. If you are dividing a z to the second by a z to the first, he's going to be down to z to the first. That's supposed to be a z. Or a better way of thinking of it, the original problem, the highest exponent was a 2, z squared. You're going to start 1 exponent less every time. All right, now, my advice, put some parentheses around this guy. And the reason for that is it will hopefully remind you you're going to do the distributive property. So I want to take that 1z that I wrote on top times both of those guys. Not just one of them, but both. So the mistake typically happens when they'll just multiply the z, the 1z, times the 1z, and they'll get z squared. But then they'll forget you're supposed to multiply that guy on top, the 1z, times the negative 4 as well. And I would get negative 4z. Okay, just like a normal division problem, if you were doing it by hand, you would subtract down. So if I subtract those z's, the z squareds, they'll cancel, right? Kind of wanted that anyway. But here's where it gets tricky also. I'm about to subtract a negative. So what happens if I subtract this negative right here? He would become positive. And now I just combine. You don't want to think in terms of add, subtract anymore. And I got 6z. Then just like a normal or a by hand division problem, you would bring the next thing down and you would start over. So again, first digit 1 goes into the first digit 6 how many times? 1 goes into 6 times. I don't have any negative signs to worry about, so that's going to have to be positive. Now the exponents always go downhill in the answer. So if I started with z to the 1, the 6 is going to be down to the z to the none, or not have a z at all. But I have to distribute. I have to multiply them both out. So my 6 right here times both of those guys. So 6 times 1z will be 6z. 6 times the negative 4 will be negative 24. And I subtract down. Subtract down, what happens to the 6z's? They cancel. And again, it'd be really tempting to say, hey, my remainder is going to be negative 48 here. But I have a subtract sign right here. And if I subtract a negative, I get a positive. The negative 24 and positive 24 makes 0. So if you look up this problem in the right corner, here's how we write the remainder. If you had a remainder of 1, we write it like that. But the problem we just did has no remainder. So there's just no reason for me to write it at all. Now, if you wanted to, you could. And I'll just go ahead and illustrate. Plus, I got a remainder of 0 out of the z minus 4 I was divided by in the first place. But there wouldn't be any point in doing that, so we don't need that. All right, number 5. More trickery, as if math isn't hard enough, right? All right, well, it's a division problem. Now notice, it is not a monomial. So if you watch video number 1, the split them up problems, I cannot do it that way, even though that's way easier. And I can't do it that way because this is a binomial. Okay, now, if we were doing notes on the board, I would let you figure this out on your own. But since we're not, I'm just going to show you. Polynomials, when doing division, are just like regular numbers. So in other words, here, I'll show you. If I did 61, well, let's do 6107 divided by 41, you would obviously put the 41 out here, but you wouldn't go 617. In other words, you wouldn't leave the 0 out. So the fact that this problem over here, number 5, has an 8x to the 4th, but it has no x to the 3rd, It's like having a place value like that problem down there in the bottom left corner. I can't leave out the 0. I got to have it. So there's no x to the thirds, and it'll probably make some more sense here in a minute. Minus 4x to the second plus x plus 4. So this is going to be a doozy. Off we go. We'll grab a different color just to separate a little bit more. All right, again, here's what you need to do. First digit 2 goes into first digit 8. How many times? 4 times. If the exponent in the original problem was x to the 4th, I guarantee you this is going to be down to x to the 3rd. Put parentheses around this. It will remind you we must now distribute those two. So 4x to the 3rd times 2x be 8x to the 4th. Now these guys are supposed to match, so if they don't match, you did something wrong. 4x to the 3rd times 1, that's what most people forget. I got to multiply them both before I do anything else. So does it kind of make sense why I needed an x to the 3rd or 0x to the 3rd in this problem? Because if I didn't, I would be sticking that 4x to the 3rd underneath the 4x to the 2nd, and that wouldn't make any sense. So if I subtract down, these guys will cancel. I subtract down, I get a negative 4x to the 3rd. Bring the next one down and repeat the process. First digit goes into first digit how many times? How many times does 2 go into 4? Twice. How many times does 2 go into negative 4? Negative twice. Is that a word? And the exponents will go downhill. So if that was an x to the 3rd to start with, we're down to x to the 2nd. Multiply both things out. One more time. This guy times both of those. So negative 2x squared times the first guy. These two guys will match up. But negative 2x squared times the 1 will give me that. Subtract down. Now what happens if you subtract a negative? Changes to positive. What happens if you subtract this other negative? Changes to a positive. I'm left with negative 2x to the 2nd. Bring the next one down. How many times does the first digit go into the first digit? 2 goes into 2 once. 2 goes into negative 2. Negative 1 times. Hey guys, x to the 3rd in the first answer, x to the 2nd in the second part of the answer. Guess what? X to the 1st always goes downhill. Multiply them both out. What's negative 1x times 1? Negative x. Subtract down. So here's another mistake that people often make. I'm subtracting a negative, subtracting a negative. So 2x total. Bring down that 4. Last one to bring down. And let's see how I'm going to fit this in here. First digit 2 in the original problem up here goes into the first digit 2 down there 1 time. So I got a plus 1. Multiply them out. I got a 2x. And 1 times 1 is 1. So subtract down. And I got 3 for a remainder. So here's how you write the remainder. We want to go back up here. So our answer is this the blue answer clear on top. So the remainder was positive 3. So I'm going to put a plus sign. If that had been a minus 3 down there at the bottom, I'd have put a negative. So there's my remainder of 3 over what were we dividing by in the first place? 2x plus 1. Whoa, that was kind of ugly, but you get the idea. All right, so these are nasty. I will admit, maybe the single hardest thing that we do all year in Algebra 2. But hopefully that made some sense to you. So that's long division. That took up 2 parts of a video, so you can tell those are monster problems. Down here coming up, synthetic division, and I guarantee you, you're going to like synthetic division way more. It's way easier. So please, if you're not following by reading the notes, tune in and watch me do some synthetic division problems. All right, thanks for watching.